the quotient rule and the addition rule, but no numerical finite differences at all here. Okay, so first of all, let me show you here, that I'm taking I'm applying the Babylonian algorithm without rewriting code to a dual number now. Before we applied it to numbers, but now I'm going to apply it to this dual number that I just invented. I'm going to apply it at 49.1 because I know the answer. And then I'm going to compare it with, I'm taking 1/2 over the square root of x just for comparison purposes, right? And not in my own algorithm. And of course, you see that I'm getting magically the right answer without ever. So you should wonder, how did I do that? How did I get the derivative? We could take any number you like. Here's 100. If you prefer to see a number like pi, we can do that. I mean, we can do whatever you like. It's going to work. So there you see this is the square root of pi, and this would be 1/2 over the square root of pi numerically. So and you see it matches these numbers to enough digits. In fact, to all the digits, actually. Yeah. So this thing magically worked. Okay, you should all be wondering, how did that happen? I didn't rewrite any code. I actually wrote a code to just compute a square root. I never wrote a code to compute the derivative of a square root. And by the way, this is a little bit of the Julia magic that we're pushing numerically. That very often in this world, people will write a code to do something, and then if you want to do something more, like get a derivative, somebody writes another code. With Julia, very often, you can actually keep to the original code, and if you just use it properly and intelligently, you can do magic things without writing new codes. And you'll see this again in a little bit. But here's the derivative of, this is the plot of 1/2 over the square root of x in black, and again, you could see the convergence over here. All right, well, I'm still not going to show you why it works just yet. I promise I will, and it's probably a few more minutes more. But what I will do first is I'd like to show you